All right. So last time we talked about normal distributions. And so what we want to do today is basically go through the idea of how to calculate probabilities when you've got a normally distributed random variable. And so I'm going to go through some problems, mainly the odd problems here near your homework, and then a couple further down maybe, just to get you kind of set up here. All right. So problem 45 will be the first one I go to, okay? So the question it asks is the probability of x less than 1 equal to the probability of x less than or equal to 1, and why is that? So again, this is a normally distributed random variable. It's going to refer to this graph here, but really it could refer to almost any graph that's normal, because it doesn't really have to do with the graph. It has something to do with, well, something else. Can you remember what the answer to this would have to be? X less than 1, is that probability equal to, less than or equal to, pardon me. I just wanted to make sure I'm recording. Yeah. Is that area less than or equal to, here we go, yeah, 1. Is the less than or equal to 1 area the same as just less than 1 area? Yes, I'm seeing a nod. Yes. Why is that?
Because it's within that amount.
Okay, actually, I asked the wrong question here. So are the areas the same? Of course they are. Are the probabilities the same? Yes, because probability is measured by area. So that's why we get sloppy. We get to be a little bit sloppy about whether it's less than 1 or less than or equal to 1. That wasn't the case back when we had the binomial distribution. We had those businesses having to kind of mess around with your calculator, and if we wanted less than or equal to something, well, then we had to maybe do some work to get a plain old less than. Okay? So, but these two are equal because equal to as a probability is always 0 in a continuous random variable like the normal. Now, says here, what is the area to the right of 3? And that might get people kind of, that's a vaguely worded question here. Because people are thinking, oh, I don't know what the area to the right of 3 is. How do I figure out the height times width? Okay, what we would do ordinarily is look this up on a table, or look this up in the StatCrunch or on your calculator. The problem with this is, of course, we don't know which normal distribution we're talking about. We don't know what its mean is. We don't know what its standard deviation is. So really, all they want us to say here is that this probability, or that the area is probability that x is greater than or equal to, doesn't matter about the equal to, 3. That's what the area to the right of 3 represents. So it probably would be better describe, what does that represent, not what is it? Because we don't know enough information to ask what it exactly is. Now, 49 doesn't really refer to this graph anymore. Okay? 49 asks a question. If the area to the right of x in a normal distribution is 0.543, what is the area to the left of x? Okay. So first of all, I'm going to get rid of this so it doesn't confuse us here. Okay, so I've got a normal distribution. I've not been told where its mean or standard deviation is. But I've got this value somewhere along this axis. And the area to the right of it has got to be 0.54. Now, by the way, what is the area to the right of this dashed line?
The same,
Same as what?
the 5.43.
No, I just drew this arbitrarily. I'm smack in the middle. So if I'm smack in the middle, what does the area to the right of this dashed line need to be? Sorry about that. A half. This is area under the curve is 1 total. So this is a half. So what I was trying to get at by doing that first and straying there is if my area to the right is 0.543, must my x be on this side of the dashed line or this side? Left or right of the dashed line? If the area to the right of wherever this x is 0.543. Yeah, it's got to be the left because you got to have a setup where more than half of the area is to the right. Okay, so here's my x. I don't know exactly where to put it, but it's somewhere over here. And hopefully I can do my little bucket fill here. So this area, oopsie, I've got something open. One little thing open. Try again. So that area has got to be 0.543. Okay, so let's continue the answer to the question here, though, which is not it. What must the area to the left of x be if this area is 0.543? What must, and notice how I'm drawing an area above the graph, not on the x-axis. So I don't get confused as to whether I'm talking about an area. You know, sometimes I'll even point into that a little bit. An area or a value of x, okay? But I'm talking about this area is 543. What must this area right here be equal to? How will we find that area again? It's got to be 1 minus 0.543. So it's got to be 1 minus 0.543, which is equal to 0.457. Okay.
What if your x is on the end?
What do you mean on the end?
Like where the graph is at the lowest point.
Now, careful about this because I had to draw with my little mouse and it's not the most accurate drawing in the world. This graph never really hits a lowest point. It's bounded below by 0, the x-axis, but what it really does is it should just get closer and closer to the x-axis without touching. So it never goes below, but it goes on forever. So it goes all the way out to infinity. That being said, last time we talked about, well, if we go 3 standard deviations out, whatever 3 standard deviations is here, and we don't know what the standard deviation on this particular one is, if we go far enough out, nearly all the area is between here. But there's no such thing as the end of this graph. Not on a normal. Make sense? It just gets closer and closer to the x-axis without going below. Okay, now for the rest of these, till we move on, we've got a distribution given to us. Normal 54, 8. So X is distributed. Where's my squiggle key? Where is that hiding? Here it is. Normal 54, 8. Which means normal distribution with what's equal to 54? The mean, or mu, is equal to 54. Mean mu is equal to 54. Standard deviation sigma is equal to 8. Population mean mu 54, population standard deviation 8, with a normal distribution. Okay? And so the first question, we want to find the probability that X is less than 30. Now, here's the problem. Your test is on computer. You're going to be doing these and referring to the computer, referring to an answer sheet to look up, hey, what's my answer? And it will just have a number. It will. But it is really important, in order to keep yourself on the straight and narrow, to draw the picture of the distribution you're dealing with and what it is exactly you're trying to find. So in this case, first of all, the distribution, we know this center, we actually know where this center has got to be. This center has got to be at mu equal 54. So numbers greater than 54 are going to be over on the right of it. Numbers less than 54 are going to be the left of it. And then above it, we write areas of whatever region we cut off there. Okay? So, but what area do we have to figure out? We want the probability of X less than 30. Okay? And so we know 30 is going to be somewhere over here, right? Because 54 is in the middle. And we want to the left of 30. And instead of using the paint tool, I'm going to shade like this because it goes on forever and I didn't cut off the end, and so it won't paint very nice. Okay? But that area is what I'm trying to find. Does that look like an area that's over half or under half? Under, definitely under. I mean, it just gives you an idea what to look for. Now, we have to actually do the looking, and this is going to vary from person to person. Let me first look at, for those of us who have StatCrunch. Okay. Oop, we have not accessed this page properly. Well, where we go? Now, to make calculations with this, just either probabilities or areas, we go to the calculators under Stat. Stat, calculators, normal distribution, and that gives us the calculator. We know our mean. We're told our mean is 54. We are told that our standard deviation is 8. And we have a particular probability we're looking for, namely less than 30. Now, when I click compute, it helps me to look at this picture. Okay, does it at least sort of look like what I've got? Well, it's not very easy to tell because 30 is way the heck down here. And so there's hardly any area. You can barely see a little red blip there. There's not much area down there at all. But yeah, otherwise it looks somewhat like this in terms of it's not an upper tail area. It's not a lot of shading. And so that probability, that lower tail area, is going to be 0.0013. Okay, that is this area right here. And that's my probability that X is less than 30. Now, see, say you don't have StatCrunch. The next thing I can do up here fairly easily is get into Excel. So in Excel, let's make the cells a little bit bigger. And what I'm looking for up in my little search area is normal. And so we have these normals, and there's actually two things that look almost alike. There's normal with an S and normal without the S. Second of all, you see is, so we want normal without the S, because the with the S means you already know your mean and standard deviation are 0 and 1 respectively. This is so-called standard normal distribution. But to just learn one command, norm dist does it. The other command we'll need later is, okay, for norm dist, we're going to find probabilities. We have a value of X. We want to find a probability associated with it. Find an area. Later on, later today, probably in one or two problems from now, we will have an area and we'll want to find the X that goes with it. That is norm inv. So if I have the X, have the value of the variable, and I want to find probability or find an area, that's norm dist. Okay? And your calculators, the TI calculators, have a similar pair of commands. There's a distribution command, a normal distribution command, and a normal inverse command. One is about finding, you've got a probability, you want to find the area. That's the inverse. Dist is the one where I've got a number, and I want to find what probability is associated with it. So I click on that. Okay. And now I've got to give it, first of all, the X. Well, the X is the value that of the variable that I'm looking for. It's not my mean. It's that 30, that boundary value. My mean was 54, was it? I believe so. Yes, 54. My standard deviation was 8. Here's where things get a little bit easier in a way than with the binomial earlier. With binomial, both true and false would give you an answer that might be worth having. In continuous distributions, the only thing that gives you an answer worth having is, true. You want cumulative probability distribution. And when you click true, what that gives is a lower tail area. It gives an area shaped like this. Now, unlike StatCrunch, you're not going to get the reminder with this little picture that shows you that. So you've got to remember that what norm dist gives you is a lower tail area. If that's what you want, we're golden. And that is what we wanted. So 0.0013 was what we got. If it was not what we wanted, then we have to go with maybe some subtraction. We'll see some problems like that, okay? But there is with this calculator here. For those of you using TI calculators, I'd like you to take 5 minutes right now. It's 11:25 right now. I'm going to give you till 11:30. Look up online what the command is to do this on your TI calculator. It will be something like, instead of norm dist and norm inv, it will be normal PDF That I know, and I'm not sure if there's a normal PDF inv, or if you just look for that. For if the normal PDF will work both ways. But the command you're probably looking for is normal PDF, and depending on what you give it, will spit back. Look for it. I'll sort of look for it up here too, but the main thing is you want to look for it on your own, because
You try that on that calculator, it gives you like a weird.
yes. Okay, so now I'm seeing them and I got things wrong. Here's what the two commands you're looking for, the second and third on this list that are showing up. Normal CDF will give you an area below. Again, PDF, what PDF will give you is the version of, if you entered true on Excel, the thing that's kind of worthless to us. We don't really care about normal PDF. Normal CDF gives us an area below. And inverse norm, INV norm, that's going to be the one we're going to use later when we have an area and we want to go back and find this, okay? So spend a couple minutes, get comfortable with, see if you can get the same answer we got for this problem. And so let's again look up this problem and show its answer. So there's this problem, show its answer. Make sure you can go into your TI calculator and get that answer if you got. What are you getting?
Well, then it gives you lower and upper.
Okay, so what you have to do with lower, that's right. The TI wants a lower end, so always wants an interval from here to here. So what you do is you give a ridiculous low end.
So can we just leave it at the one that it gives us?
What's the one that it gives you for the low end? Let me see. Yeah, that's, in other words, that is -1 times 10 to the 99, so it's -10 million. That's, so some of them are programmed to give you a low end, but give just a huge low end, like -1 million, something like that.
So then what do we do for the upper?
For the upper, so this is picture -1 million is way down here. The upper is right here.
So we would do 30.
It would be 30 in this case. It would be 30.
But you need access. Maybe that's access lower. Yeah, and that's what Excel gives you. That's the first time.
Lower, upper, yeah.
I think so.
So what you're trying to do always with the TI is get the two ends of the interval, but if the one interval doesn't have an end, you just use the end they have by default.
If it's greater than or less than.
With a greater than, what you do is you'd make the upper end huge, 1 million huge, and then the lower end would be whatever you want it greater than. Okay, we'll probably see that in a problem.
And then that one? No.
Now I got points. Yeah.
That's like any other time. Like that? Yeah.
Okay, so.
No, they don't give us one, so we're gonna have to make one up. Let's make one up.
Well, number 50 has a greater than.
I know it does, but you know, that's your homework. So I'm going to make up another one. Because I want one that you have to do on your own. So let's look for probability of X greater than 75. Let's say we're after that. So again, we draw a picture of the normal distribution. This particular one is normal with mean 54. So 75 is somewhere up here. And this area up here happens to be what we want. So on StatCrunch, I go with greater than or equal to 75, hit enter, and now I can see what looks a little bit more like an area because you can see some shading here. It's a lot more red shading. That, sure enough, is an upper tail area. It looks roughly like what I've got here. Whereas, for example, if I'd left this with less than, you'd say, wait a minute, that doesn't look at all like a teeny upper tail area. Okay? So that's getting it on StatCrunch. In Excel, what we would do is go to the function key. Now norm dist is still there, so that's what I want. And my X now is 75. My mean is 54. Standard deviation is still 8. My cumulative is still true. But now here's the slight problem. It's giving me this number. Why is it such a huge difference from what I actually calculated in StatCrunch? Well, remember what Excel always does is give you this area right here, a lower tail. That's always what Excel gives. So 0.995, let's go to one more digit, 9957 is my lower tail. Therefore, what I'm interested in, the upper tail, is 1 minus that. Which is 0.0043. Okay, let's just see how consistent that is with what I got in StatCrunch. Yep, 0043. Okay. And again, in the binomial, in the calculator, in the you're going to use the binomial CDF command. You're going to start. The low end of your interval is now 75 because that's, and then think of it's from here to here. Low end is 75. Upper end is now the one we're going to have to make up some huge number. Okay? And you'll get roughly 0.0043. Okay? Now let's look at the next problem. So there's 51. 53, different question. And again, it helps to draw the picture. Really important to draw the picture and know what it is you're looking for and what it is you've got. So I've got the same distribution. Normal distribution, mean at around 54. But what I want is the 60th percentile. Now, 60th percentile isn't a number down here. I mean, that's not 60. 60th percentile is some mystery number down here, which beats half the, or 60% of the data and loses to 40% of the data. Now, how did I know to put this X on this side of the 54? It's more than 50% of its lower. So it's going to be over half the data. So we throw this little line in here and cut this off. And then what I'm going to do is a teeny little one so I can do a quick shade. And let's see if it will let me shade quickly. Yeah, good. So what do we know about that area I've just shaded in green? What do we know about that area I have just shaded in green? How much area has that got to be? 0.6. That's what we know about it if we're dealing with the 60th percentile, is that the lower tail area is 0.6. So if we know the lower tail area is 0.6, now we have the tools to go into whatever program we're using. Let's look, for example, at StatCrunch. StatCrunch, I've got the mean, got the standard deviation. I've got lower than is what I'm interested, but I don't know what goes here. What I know isn't a value of X. It's a lower tail area. So 0.6 is what goes here. And so I've got a picture. It looks roughly similar to what I've drawn. It's got 0.6 as its area and some number here. And so what must our X be equal to?
Wait, can you say that again?
What must our X be equal to if it's the 60th percentile? 56, right? It's this right here. It's the X that makes this the lower tail area. Now, the command you're going to have to use, let's go back, in Excel is going to be different. In Excel, we are away from norm s dist or normal dist, and we are now, let's look up again normal, so we get it among our things. This is where we have to use this command called norm inv, because what we have is an area, a lower tail area, 60%. What we want to know is the X that cuts it off. So I go norm inv, and first thing it's asking for is a probability, 0.6. Wants the mean of the distribution, 54. Wants the standard deviation of the distribution, 8. And sure enough, you can already see what's going to happen when I hit a turn. Down here in this little corner, it lists it already. 56.026 is my 60th percentile. Okay? So if I've got an area, I go to norm inv. In the calculators, it's inv norm. So for those of you with TI calculators right now, try to see if you can get that answer, pick the right command, inv norm, and enter the right stuff. And I'm not sure the syntax of inv norm on there. So you have to look up and see what it gives you and what makes sense. But again, what your number you're hoping it spits out as an output is 56. If you've got that, it's probably you've got it in there right. Let's look at 55. Problem 55. I've got a normal distribution. -3, 4. Okay, which means I am dealing with a normal curve whose high point, whose mean and median and mode is all the same at -3. That's what's at the center here. And what we are asked for is find the probability that x is between 3 and 9. So 3, careful, not -3, is somewhere up here. Yes. Did I?
Maybe you read half.
Okay, I did.
1 and 4.
So 1 and 4, thank you. Thank you. That makes an easier thing to look up too. No, -3 is still my center. But what about between 1, which is somewhere out here, and 4, which is also somewhere out here? This is the area we want. And in the days of having to look stuff up on tables, that was harder to find. Now, most of our stuff on computing makes it a little easier, except for Excel. Excel is going to be, we're going to have to do a little bit of work to get this in Excel. Not much. Okay, so let's first of all go to StatCrunch. StatCrunch is a between button. So I can go from 1 to 4. Still not going to give me much because I've got my wrong mean here. My mean is now -3, and my standard deviation is now 4. And there I've got a picture. It looks like the picture I've drawn, and it's giving me an area 0.1185 or 0.119. Okay, so there's that area we've got. ACK. Typewriter. Here we go. 0.119. And we will change this to black and draw a little arrow into the region to depict that I'm showing an area of a region, not a value of x. So 1 and 4 and -3 are values of the variable. 0.119 is the area of this region, or the probability of x being between 1 and 4. Now, crowd. Okay. So, got this here. On your calculator, you get the same thing, because that's why they have that low, the thing that was so inconvenient of, well, I have to make up this low end or I have to make up this high end. Now, when it's a low end and a high end, oh, you just enter 1 and 4 for your low and high, right? No problem. It's just it's just as simple as that to get that picture. Okay. But what about Excel? If you're on Excel, what you have to do is go, first of all, we're going to break it up pictorially. This is what we're going to do. I'm going to think of this curve, of this area that I've just gotten, as being this lower tail area. See the stuff all the way below 4. And then I'm just going to rip away this white zone, which is all the area below 1. Start with the area below 4, everything, and rip away this white zone that's below 1. Probability of x less than 4 minus probability of x. So what we have to do is we have to go in here, function key, Norm dist, because we've got values of x, and we're looking for an area that goes with them. My first x is going to be 4, mean -3, standard deviation 4, cumulative is always true on these normal ones. Okay, then the second one, I'm going to go the same command, but this time my x is going to be 1. My mean is still going to be -3. My standard deviation is going to be 4. And cumulative, as always, is going to be true. So this is the whole blue slice below 4. This is the slice below 1. And to get this, okay, I'm going to just subtract. I'm going to go equals this guy minus this guy. And there I get that 0.1186. I believe we rounded to 0.119 back here. Yeah. So in Excel, you have to do that business of that's going to be really critical to have the picture, but it's always critical because you got to know what it is you have and what it is you're looking up. Otherwise, it gets very confusing as to which command you have to use and what you do with the output. Do you leave it alone? Do you subtract it from 1? What do you do with the output? All that stuff gets very confusing if you don't have the pictures to guide you. So with that, we haven't got much time left. But yeah, take those few minutes to get started on, at least started on this assignment, the odd problems on this page.